All right, let's just jump right in. We're going to tackle a huge, and I mean huge, question today. How in the world do the biggest companies on Earth manage the millions, literally millions, of computers that run our digital lives? The scale is just mind-boggling, but the solution, well, it's actually surprisingly simple once you learn to think about it in a whole new way.
I mean, really think about that for a second. You hit play on a movie, you're scrolling your feed, and at that very instant, millions of other people are doing the exact same thing. How does that entire system not just, I don't know, melt? It's not one giant supercomputer, that's for sure. It's an army. And how you manage that army, that's everything.
And there it is. That's the secret sauce. This is probably the single most important mental shift in all of modern computing. Now, it might sound a little harsh, I get it, but this one idea, pets versus cattle, is the key that unlocks the kind of scale we see every day. So let's break down what that actually means.
To really get the new way, you got to understand the old way. So let's go back in time to an era where every single server was treated like like a beloved family pet. Picture this. You have a dog, let's call him Sparky. You gave him a name, right? You know all his weird little habits. And if he gets sick, you're not just going to throw him out. You rush him to the vet, you spend all night nursing him back to health. Losing Sparky would be a disaster. And believe it or not, that's exactly how we used to treat servers. Each one was unique, hand-configured, and when it broke, some poor systems administrator would spend hours, sometimes days, carefully fixing it. That's fine when you have maybe 10 servers. It completely falls apart when you have 10 million.
And this, right here, lays it all out. This is the aha moment. The pet model is all about the individual. The cattle model is all about the health of the herd. You see, you don't give a cute name to every cow in your herd. They get an ear tag, a number. And you don't perform super expensive surgery on one sick cow. You simply replace it to protect the rest of the herd. And that is the crucial, brutal truth. At the scale of a company like Netflix, you don't care about server number AXB9473. You only care that you have 50,000 healthy servers running at all times.
So this new way of thinking, this whole cattle model, it actually has a formal name in the industry. It's called fleet management, and it is the engine that runs the modern internet as we know it. The two words you really got to grab onto here are interchangeable and automated. In this world, no server is special. Any one of them can be swapped out for an identical copy at a moment's notice, and the whole thing is handled by machines, not people. We're not focused on the health of one tiny part anymore, we're focused on the health of the entire system. Okay, so you've bought into the idea. Servers are cattle now. Awesome. But how do you actually herd millions of them? You can't just have some guy with a mouse and keyboard clicking around. No way. You need a set of incredibly powerful, automated tools. I like to think of them as the 4 superpowers of fleet management. Our first superpower is all about one thing: consistency. You've got to make sure that every single one of your millions of servers is a perfect identical copy. And to do that, you need a master blueprint. The technical term for this blueprint is a server image. Just think of it like the master file for a 3D printer. It has everything you need to create a perfect server from scratch. The operating system, all the software, every little setting is already baked in. It's basically the perfect recipe for a soldier in your server army. So, what does this look like in the real world? Let's say a huge new album drops, and Spotify's traffic just goes through the roof. An automated system immediately says, whoa, I need 1,000 more music servers right now. It doesn't ask a human to build them, it just tells the system, hey, use the standard music streamer blueprint and stamp out 1,000 perfect copies. And within minutes, all that new power is online and ready to go. So you have the blueprint. That's great. But how do you actually create those servers whenever you need them? For that, you need our second superpower, an automated, on-demand vending machine for pure computing power. The fancy term for this is automated provisioning, and it's basically the magic that takes a completely blank piece of metal and turns it into a fully functional server, ready for duty without a single human ever touching a keyboard. So get this. The software itself realizes it's getting overwhelmed and needs more power. It sends out an automated SOS to the provisioning system. That system grabs a blank machine, slaps the master blueprint on it, gives it an address, and boom! A brand new server is online and ready to work in seconds. It's just incredible. All right, this next one, this is the big one. This is the brain of the entire operation.
You've got millions of identical servers that you can create in an instant. Now you need someone or something to tell them all what to do. You need an army general.
This is called orchestration. And look, if you spend any time in the tech world, you are going to hear the word Kubernetes. Kubernetes is the five-star general for pretty much every major tech company's server army. It's the software that turns a chaotic mob of computers into a coordinated, unstoppable force. But here's the really mind-blowing part about an orchestrator. You don't give it a list of step-by-step instructions. You just give it a goal. You say, hey, Kubernetes, my goal is to have 500 copies of my login service running always. And the orchestrator figures out the rest. It finds 500 healthy servers, puts the code on them, and then, this is the most important part, it watches them. If one of those 500 servers dies, the general sees it instantly and automatically kicks off the process to replace it.
Which brings us to our final superpower. How does the general even know when a soldier is sick or has fallen? In a fleet of millions, you can't have people doing manual checkups. You need an automated immune system. You need the robot medic. Now, this is really a two-part system. You've got monitoring, which is like the eyes and ears, constantly collecting billions of data points from every single server. And then you have self-healing, which is the automated response. It's the system that sees a problem and fixes it without ever waking up a human at 3 a.m. And this is where that cattle mindset is just crystal clear. Every server is constantly sending out a little heartbeat signal that says, I'm alive, I'm healthy. If that heartbeat stops, or if it reports some weird error, an alarm is triggered. But what happens next isn't a repair job. Remember, that's the old pet model. The self-healing response is cold, efficient, and immediate. The orchestrator simply terminates the sick server, poof, it's gone, and provisions a brand new, perfectly healthy one to take its place. The mantra is, replace, don't repair. So let's put all the pieces together. Let's see how these four incredible superpowers combine to create this invisible army that powers the services you and I use every single day. It's actually a really beautiful and logical system when you think about it. The blueprint gives you consistency. The provisioning machine gives you on-demand scale. The orchestrating general gives you intelligent command and control. And the robot medic makes sure the fleet is always healthy by just replacing any fallen soldier, never wasting time to repair it. And that, right there, is the secret. The next time you're scrolling on TikTok or watching a show on Netflix, just remember, you're not talking to one special handcrafted computer sitting somewhere. You are being served by one tiny, anonymous, interchangeable part of a massive, constantly shifting, self-healing fleet of millions of machines, all managed like cattle, not pets. You know, this mental model is just so powerful, and it applies to way more than just computers. Think about ride-sharing networks, package delivery logistics, even modern farming. So the question I want to leave you with is this. Where else in our world do you see this fundamental shift from managing precious individuals to managing a robust, interchangeable herd? It's happening everywhere.